Welcome to Cheese Code by Roman Dmitri. Today we're expanding our Monorepo with the React service. See the code for yourself in the stub repository, specifically version 0.1.0. I'll leave a link in the description below. The biggest change today is the creation of the stubb-react service. But I have also updated the stubb-proxy service to route the requests, and have created stubb-design service to keep track of assets such as the logo. This is our first real service. It uses React with Webpack, TypeScript, and Yarn. We'll start exploring at the root of the React setup and work our way out through Webpack, the Docker image, and Docker Compose. Then we'll tunnel back in through the stubb-proxy to expose this new service. In the end, I'll demonstrate that hot reload will work on any device on your network, such as your tablet or your phone, whatever. There's a lot to cover, so buckle up. So let's go through the services. We'll have stubb-design, stubb-react, and stubb-proxy. Stubb-design, let's get this out of the way. I've created a pseudo service for keeping track of our design assets. The source files are here instead of Figma because for now it's lightweight and easily accessible. I keep exports in the public folder so I can easily copy and paste them into any service that I create. I have the logo file here, for example. And let's leave it at that. Let's now look at the stubb-react service folder. This is the main event. I assume you know what React is and have worked on it before, so I'll skip the introduction. The goal here is to demonstrate how to add a React service to the stub monorepo. This is a service that might one day split into a separate repository, so we started off with its own git ignore file. Then, like every node project, we throw in a package.json file. Who is JSON? I assume you know how to work with this file, so I'll just highlight the script section. I have created a local serve command that uses Webpack to load our React code. This will be our entry point into the local Docker container. TypeScript. TypeScript is for type checking and code completion. For TypeScript, we have a tsconfig.json file. The most important line here is the @/source override. This allows for absolute import paths in our code. This improves readability and contextual awareness. I find the default relative path approach to be quite disorienting. /where am I? Webpack. Webpack loads, parses, and bundles our code. Webpack runs on Node. More on that later. Here, Webpack is configured via multiple files, a base file and an environment-specific override. The base file is shared across all environments. The most important tweak here is using @/source for absolute paths, similar to the TypeScript config that I just mentioned. The local file is configured for development mode and uses Webpack dev server. Pay attention to the WebSocket URL here. This is key for getting hot reload to work through the nginx stubb-proxy service. This value tells the front-end code where to find the back-end server. There's no way to change the route that the back-end server actually listens to. Believe me, I've tried. In the last video, I created stubb-proxy to run on port 1200. For this video, I have updated the nginx configs to allow for a WebSocket connection on this path. I will demonstrate this when we dig into the stubb-proxy changes. envs. Environment variables are loaded from our container into Webpack using the .env plugin, specifically saying system vars equals true. In the entry configuration, we specify our env.ts file. Here we expose just the desired values from our node process into a global window variable for React to read from. The config.ts file has an example of that. Docker file local. We have a dedicated Docker file for local development. This starts as a node image because Webpack needs node to run. At the top, I install tools that I most often use for debugging and troubleshooting. At the bottom, I solve a permission issue by assigning the host user and group IDs to the container user. Specifically, we have our entire service folder mounted as a read-write volume inside the container. When we execute yarn install, a set of node modules will be created in the mounted folder. Under default configuration, these files will be owned by root and your host user will have no access to modify them, and your life will be a bit of a struggle. A lot of a struggle. By updating the user and group IDs like we've done here, all those files will be owned by the host user instead, and then you can modify and delete them as you please. That's great. Makefile. The makefile. We have a dedicated makefile for this service. The most important make target is stubb-react local run. This target builds our local Docker file, then runs the container and executes the commands. This is intended to specifically run beside our Docker Compose container. In fact, the stubb-react local install target runs before the Docker Compose containers even spin up. The target points to our local install script, local install.sh. The most important line here is yarn install, which installs the dependencies in our package.json file. Specifically, this downloads and installs Webpack into our node modules folder, so that when the container actually runs, the Webpack package will be available. This avoids a chicken-egg situation with our boot script the first time you run it. By the way, I use yarn instead of npm because yarn is faster at checking for already installed packages. Otherwise, it makes absolutely no difference. I like to copy the relevant node and yarn binaries into the bin folder to expose them on the host machine. This helps my IDE know which version of Node that I'm targeting, because I don't even have Node installed on my host machine. Docker compose.local.yaml. Let's take a look at our Docker Compose file for the stubb-react service. Side note, I decided to have a separate Docker Compose file for each service to keep files as close as possible on a per service basis. Our main Compose file is quite empty now and references other Compose files. Anyway, back to the stubb-react service. Here, we specifically publish the port 1210. This value is completely arbitrary, but our proxy is 1200, and I suspect we'll have multiple front-end services, so we'll keep them base 10, 11, 12, 13, etc. The backend services might be 21, 22, 23, you get the idea. For volumes, we mount the entire service folder, so all contents are available inside the container. We also mount the common scripts folder to expose utility functionality, such as logging, colors, and other fun stuff. The command is yarn local serve, which kicks off our Webpack dev server, as previously mentioned. I've updated the stubb-proxy service to forward requests to the stubb-react service. Let's take a look at that next. The proxy. Stubb-proxy. This is the ingress into our local environment and is responsible for routing traffic to the rest of the services. The goal of the proxy approach is to simulate a production routing environment. This way, we can reduce the need for routing configuration changes once we start with server deployments. We created stubb-proxy in the last video, and now I have made a few updates to expose the stubb-react service. Docker compose.yaml. First, in the compose file, I am overriding the nginx config and the default template files. I am also mounting the source folder to var dub in the container. nginx config. The config file is copied directly from the nginx image. I like to have it exposed because I sometimes like to make changes to the logging format or other settings. Default config template. This file is where the magic happens. Abracadabra. Ooh la la. At the top, we define the IP local variable, which pulls from the environment stubb-proxy IP value. But where does this come from? That's a great question. Let's follow the make local boot command. In the root make file, the local boot target executes the local boot script. The local boot script loads utility.sh and calls the prepare environment function. The prepare environment function calls host IP function. The host IP function checks your operating system and runs the appropriate command to get your local IP address. If a value is determined, the secrets override file is updated, specifically setting the stubb-proxy IP value. In our Docker Compose file, we use the env file section to specify the env files that we want to load into the container. And once the container starts, the env values become available. Success. Awesome, we have our IP value. The first location block specifies a proxy pass from the /react path to port 1210. This is the same port that we published in our Docker Compose file. Be sure to add the arguments at the end, otherwise you'll have a bad time. The second location block specifies proxy pass to the Webpack WebSocket for hot reload. As mentioned previously, the Webpack socket is always at the WS path. You cannot change this. In the source folder, we have a simple HTML file which displays the service name. In a future video, we'll turn this into a health status display, make it clickable, and give it jazzy fingers. Or is it spirit fingers? I think it's spirit fingers. Well, that should cover all the key changes, so let's see it in action. Demonstration. Let's do a demonstration. First, we'll just run the boot script, and then I'll show you the hot reload functionality. Boot. Running the script. Make local boot. Bleep lord. Wow, that was fast. That only took 2 or 3 seconds. Yeah, we have one service, so it's not going to take very long. Note, I do have my images pre-downloaded and installed. If it was a fresh install, it would take about 15 seconds. If you want to try it for yourself, just run make local prune and then make local boot again. Okay, let's see the proxy. The proxy is up and running on port 1200. It's not too exciting. We'll jazz it up in a future video. Now let's go to /react. Nice, we have something. Nice, very nice. For now, it's just the service title and environment variables. We discussed earlier how to expose the environment variables from the container to Webpack and then the window object. In the config.ts file, we parse variables from the window into the runtime. On my host machine, I use localhost port 1200 in the browser, but I use the IP on my mobile devices. Let's see this on my tablet. This is what it looks like on the tablet. How freaking awesome is that? Success. Now I'm going to press Ctrl S on my keyboard. How freaking awesome is that? It updated with a hot reload and it just works. Okay, that's awesome. Now let's show off the make stub local logs command. This is the output from Webpack inside the container. I keep this open during active development just to be aware of the errors that might show up. If I make changes that require a container restart, I use the stubb-react local restart command. This essentially restarts the Docker container and then goes back to logging. One command, it's very efficient. Well, that's it, guys. We did it again. Let's go to conclusions. Conclusion. Let's summarize what we have accomplished. We have added a new service called stubb-react that hosts our React project. The project uses TypeScript and loads locally using Webpack dev server and has a functioning hot reload. All of this runs inside a Docker container. A container that is accessible through our stubb-proxy load balancer, which helps simulate a production environment. And to get all of this running, we use a single make local boot command, which only requires Docker on your host machine. I don't even have Node installed on my host. That is truly amazing. Guys, we are just scratching the surface. I wish there was more time in a day. In a future video, I'll show you how to add a backend container, a database container with schema migrations, and how to seed data with import scripts, all using one command. Guys, exciting times. Thank you for watching. I hope you found this informative. If you have any questions, comments, concerns, just leave them below. I love you all, and I hope you have a sunny day.